we started talking about wind load. So I need everybody to pay attention more about how to calculate wind load. First step number one, we need to calculate the fluctuating pressure using this equation. QZ equal 0.00256 KZ, KZT, KD, V square. We have different parameters, but the most important parameter is KZ, depend on the height of your building, based on this table 15, and V square, and this is the velocity of the wind mile per hour. And according to ASCE 7, we have a map for United States based on the location of your structure. I can figure out the velocity of the typical velocity of wind in mile per hour. KZT, KD, most of the time we are going to assume them 1. And after you get QZ, we are going to use this expression to figure out the pressure of your wind. Keep in your mind, I forgot to mention, this is QZ. Times G is a constant, equal 0.85. CP based on these two tables. We have tables for the windward wall and the leeward wall for your wall pressure. If you are talking about the roof, this is the windward roof, this is the leeward roof. We have example here, and we started to solve this example last meeting. The wind direction is coming from here, and this side will be called windward wall. The other side will be called leeward wall. The top of this building, this side will be called windward roof, and this side will be called leeward roof. If you have any question at any time, just let me know. So before starting, you have to understand this concept. One more thing. This is your building. Looks like the elevation from this side. The elevation of this building looks like this. We are going to use a term called H. H is in this type of structures is measured like this from the bottom until the average height here. This is your H. This term is very important. So if you look to the given isometric, this height is given 25 feet, and this angle is given 10 degrees, and this half distance equal 75 feet. So I can set up right angle triangle, this one. So this distance 75 feet, this angle 10 degrees. So I can figure out this one. Based on 10 degrees multiplied by 75, this height will be 13.2. Average of 13.2 divide 2, and then I will add the result to 25. So the height will be 31.6. This is the first step before starting to calculate your wind load. Any question, guys? Do you have any question? If you have any question, let me know at any time. Then I'm gonna start with the first step. which is the fluctuating pressure. Fluctuating pressure, QZ equal this expression. QZ equal 0.00256. KZ, I will not use any value for KZ because it depends on the height. KZT1, KD1, V square in this example, like we covered last meeting, located outside Chicago, Illinois. The velocity will be 105 miles per hour. It will be square. This is the value of QZ. I can get it, simplify 0.00256 times 105 square. I got here 28.22 kz. Since we have a table here for every height level, we have a value for kz. So I will divide my QZ that I got for different elevation. QZ from 0 to 15, QZ from 15 to 20, QZ from 20 to 25, QZ from 25 to 30. These divisions based on the values in this table. It's not my selection. From 0 to 15, 15 to 20, 20 to 25, 25 to 30, and so on. The value of KZ for each one, 0.85, 0.9, 0.94, 0.98. So I will multiply this value 28, 22 by 0.85. 28.22 times 0.9. 28.22 times 0.94. And the last one by 98. 0.98. 28.22 times 0.98. So your values, 28.22 times 0.85, I got here 23.9. 28.22 times 0.9, I got 25.4. 28.22 times 0.94, I got 26.5. 28.22 times 0.98, I got 27.6 or 0.7. Keep in your mind, since H equals 32.6, which is very close to this level, I'm gonna assume also this value is a special value. This value will be called also QH. So we have different values for QZ. I'm gonna use them, but keep in your mind the last one at the elevation, very close to your QH, your H value, your height of the building. So I'm gonna call this value also QH. Do you have any questions so far? If you have any question, just let me know. Okay. Next step, I will start to calculate the wind pressure. Keep in your mind, we have different parts of this house: windward wall, this side of the building. So I'm gonna start with this side, windward wall. For windward wall. Your equation of pressure equal QZ times G times CP, I think. QZ times GCP minus QH times GCPI. This is the equation. So let's start. I'm gonna calculate the pressure from 0 to 15 feet level. The value of QZ at this level, you already calculated it, equal 23.9. That makes sense? The value of G is a constant. The value of G is a constant based on the wind gusset effect, 0.85. So I'm gonna use 8.85. The value of CP, the value of CP for wall pressure, windward, equal 0.8. This is the value of CP. All the time, this value equal 0.8. So we'll put it 0.8 minus QH. We have a special value for QZ. The special value for QZ at the top equal also QH 27.7 time the value of GCPI is given here. It's a constant value equal plus or minus 0.18. Plus or minus 0.18. So plus or minus 0.18. Which value I'm gonna use? The value that will give you higher value. For example, we have two options right now. We have two options. 23.9 times 0.85 times 0.8 minus 27.7 times positive 0.18, or 23.9 times 0.85 times 0.8 minus 27.7 times negative 0.18. What do you think? Which one will give you the biggest value? I think the second one, because if you multiply positive, negative, which is original in the equation, by positive here will give you negative, and this negative will reduce this value. However, if you multiply negative by the negative value here, both of them will give you positive, so this term will be added to this term. For example, this one, the second term, the second option will give you 23.9 times 0.85 times 0.8 plus 27.7 times 0.18. I got 21.2. This is your pressure bound per square feet. This is the wind pressure. This is the wind pressure on this building from 0 to 15 feet height. This part of the building, we have pressure of wind equal 21.2. We have another point. We have another value if we are using this option. So we have 23.9 times 0.85 times 0.8 minus 27.7 times 0.18. I got here 11.3. This option give you 11.3. This option give you 21.1. I'm gonna use the second option. So this term, which is called GCPI, is given by the code by a value positive or negative 0.18. Which value I'm gonna use, positive or negative? Use the value that will give you better or greater or bigger value or bigger pressure. That makes sense? That makes sense? If you would like, try the both values, get your value and use the biggest one. This is the wind pressure at elevation equal 0 to 15. We have another pressure from 15 to 20. Your value of QZ at this elevation, this one equal 25.4. 25.4 times 0.85 time 0.8 minus 27.7, which is QH, time, I'm gonna use the negative value. This value or this option will give you a better or a bigger value. So 25.4 time 0.85 time 0.8 plus 27.7 time 0.18. I got here 22.3 pound per square feet. Looks good because your value when you go up is going up, growing. The wind pressure is going up when you go up by the height. Your pressure of wind from 20 to 15, I'm gonna use the value of QZ from 20 to 25. I'm gonna use GCP minus QH time this constant. So the value of QZ at this elevation from 20 to 25 equal 26.5. 26.5. Time G is a constant, times CP is a constant, minus QH 27.7 times negative 0.18. This pressure will be 26.5 times 0.85 times 0.8 plus 27.7 times 0.18. I got here 23 pound per square feet. The last pressure from I'm sorry, this is 25, not 15. The last pressure from 25 to 30 equal QZ at this elevation. I'm going good. Yes. QZ at this elevation, which is 27.7 time 0.85 time 0.8 minus 27.7 time negative 0.18. Your value will be I got here 23.8 pound per square feet. I highly recommend after you are done with the Windward wall, I will draw, assuming this is my wall from 0 to 15, from 15 to 20, from 20 to 25, from 25 to 30. From 0 to 15, I have this pressure. How much? 21.2. From 15 to 20, this pressure becomes bigger, a little. How much? 22.3. 22.3. From 20 to 25, 23. So this pressure becomes bigger a little bit. 23. From 25 to 30, the pressure becomes bigger a little bit, like this, 23.8. And keep in your mind this pressure on Windward wall of your building, and this pressure is pound per square feet. This pressure is pound per square feet. This pressure acting on this side of the building. Surface load, pound per square feet, but this pressure is not constant. This pressure becomes bigger when you go up. And that makes sense based on this table. Based on the factor KZ. Any question so far? Do you have any question so far? It's a systematic calculation. It's not hard, but you need to be more organized when you are solving this kind of problems. Okay, next step. I'm gonna talk about the Leeward wall, the wall in the back. So I will write here for Leeward wall. For Leeward wall, we have only, we are going to use this expression. QH GCP minus QH GCPI. That makes sense? So we need to follow what is written here. The first term is variable. If you look here, the first term looks like this one, which is written here, QZ. But the first term is different. So your equation will be something like this. Your pressure equal QH times G times CP minus QH times G CPI. This is your equation for Leeward wall. Keep in your mind the first difference between Leeward and Windward. We are using here QZ, which is variable by height. So your pressure is variable by height. At this moment, no. For Leeward, we are going to use QH instead. QH is a constant value. We know this value. QH equal 27.7. 27.7. G is a constant, 0.85. Times CP. For CP, we are going to use the same table for work pressure, but for Leeward. We have different values. Most of the time, your value, I'm going to use 0.5. Actually, you have to figure out what is the ratio between L and B. L is the length or the width of your building, and B is the length. So in our problem, your B equal 150. Your L equal 150. This length is called L. This length is called B, 150. If you divide L by B, you are going to get 1. If you divide L by B in this range from 0 to 1, I'm going to use 0.5. If you have something different, go ahead and use the different values. But in our case, I'm going to use negative 0.5. But this is how to use this table. One more time. This is how to use this table. We are using Leeward wall. We have different values, negative 0.5, negative 0.3, negative 0.2. Which value I'm going to use based on the ratio between L and B. L represent, if you look here, this is L, the width of your building, and B, the length. In our problem, this length equal 150 and this length equal 150. It's a square. So if you divide L by B, 150 by 150, you are going to get 1. From 0 to 1, we are going to use negative 0.5. So the value of CP is negative 0.5. Negative. Minus QH 27.7. Time. We have two options here. We can use negative 0.18 or positive 0.18. What do you think? Which one will give you the biggest value? Keep in your mind, this term will be negative because we have negative 0.5. The other term, if the other term is negative, that means we will add them together and the final value will be negative. So I'm going to use negative 27.7. I'm going to use the positive value. In this case, I will get negative value, but the biggest value. So 27.7 times 0.85 times 0.5. I got here negative 16.7 pound per square feet. If you would like, and I highly recommend, go ahead and draw this side of your house from 0 to 30. This is the highest, or 25, whatever. Because your height here is 25. I'm talking about this side. That makes sense? Looks like we have question. How did you choose 27? Alexander, QH is the value of QZ at the highest point of your building. At the beginning, I told you your H equals 31.6, which level here is very close to 31.6, the level at 25 to 30. This is the reason why I choose this value is the same value for QH. That makes sense? QH means the value of QZ at H equals 31.6. So we have a value here for QZ at the level of 25 to 30. This is the nearest elevation, nearest to H equals 31.6. That makes sense? Okay. So from 0 to 50, we will have this constant value. Wait, I have a mistake here. This value is not pressure. This value is suction. Here is your wall. This is a vertical wall, which represent this wall. So your pressure is suction, equal 16.7 pound per square feet. How did you know it's a suction? Because we have a negative value. That makes sense? And this is what I told you before. I think if you have wind, we have pressure here, we have suction here, and we will have suction here, and we will have suction here. Keep this in your mind. The wind effect on any building, from the direction of the wind, we have pressure. Any other side of the building, we will have suction. And keep in your mind, from the side of pressure, which is called windward, the pressure will not be constant. The pressure will be variable based on the elevation. Any other side, the pressure of or the suction of wind will be constant. So right now, I am done with the windward, leeward wall. Let's do this side of the roof, windward roof. I will talk about windward roof. Keep in your mind, please look to this diagram. For this part of the equation, I need to follow it. QHGCP. Looks like we will have the same equation for the leeward. Your pressure equal QHGCP minus QHGCPI. We already know the value of QH from the first step we did. The value of QH, which is the value of QZ at the highest level, 27.7. G is constant, 0.85. The value of CP, in this case, we are going to use different table, which is this table. anything related to the roof, we are going to use this table. But we are talking about the windward roof. So windward, this one. If you remember your angle theta equal 10, for angle theta equal 10 degree, and your H divide L smaller than 0.25, I'm gonna use negative 0.7. What is the meaning of H? The height of your building, which is 31 feet, around 31 feet, 0.6. Your L, which is the length of your building, 150 feet. This is your height, 31.6. This is your value of L, 150 feet. If you divide this one by this one, I will get a value of 31.6 divide 150. I got 0.21. This value 0.21 in the range of smaller than 0.25. This is the reason why I used 0.7 negative, because in the windward pressure roof, we have different value, 0.7, 0.9, 1.3, all of them negative. Which value I'm gonna use based on the relationship between H and L. H and L in our case equal 0.21, which is smaller than 0.25, so your value will be negative 0.7. Minus QH, 27.7, time, we have two options. I can use negative 0.18 or I can use positive 0.18. Which one I'm gonna use to give you the biggest value as a negative value? So I think I'm gonna use the positive value. So your value will be 27.7 times 0.85 times 0.7 plus 27.7 times 0.18. I got negative 21.5. That means your windward roof, which is this one, represent this side of the roof. We will have pressure suction like this. Suction means the air is coming out from the roof. And your value equal 21.5 pound per square feet. The remaining one is the second part of the roof on the other side, but it is called Leeward. So for Leeward roof, please follow what's written here. This term will be used instead of this term. Looks like we will have the same equation. Your pressure equal QH times GCP minus QH times GCPI. Your QH 27.7. The value of G is constant 0.85. But for CP, we need to use this side of this table. Leeward angle, your angle equal 10, and your value is smaller than 0.25, which is H divided L. I'm gonna use this value, negative 0.3. So we will have here negative 0.3. Minus 27.7, I'm gonna use a positive value, which is 0.18. This one will give you the biggest value. So 27.7 times 0.85 times 0.3 plus 27.7 times 0.18. I got here 12.1 pound per square feet. And this one is negative also, so it's a suction. So if you are talking about the second part of the roof, we will have this suction, which is constant, to 12.1 pound per square feet. If you are professional, I highly recommend at the end of your calculation to draw your building like this. This height is 25 feet. So I have here value from 0 to 15. From 15 to 20, from 20 to 25. So I have these values like this. Where are these values? Here you go. 21.2, 22.3. 21.2, 22.3. And then from 20 to 25, the value equal 23. For this part of the roof, we have suction. We just calculated it. How much? Which is called Windward roof, 21.5 pound per square feet. For this Leeward roof, we have this suction also. How much? This load, 12.1 pound per square feet suction. For the Leeward wall, we have this suction constant value. How much? If you remember, to 16.7. Pound per square feet. This is called pressure of the wind on your house or this building, which is given here in this example. That makes sense? That makes sense so far? We are not talking with pressure as uniform distributed load. We have to convert this distributed load to concentrated load at each joint of the truss. So we have another step. Your pressure that you calculated at the roof must be multiplied by A prime times S. And your wind load on the side, this side, or this side must be multiplied by S only and will remain distributed load. Guys, do you remember what is the meaning of S? S is the spacing between main system based on your layout. A prime is the inclined spacing between purlins, this distance. So this shape will be converted to your truss. We have truss. Like this. Your pressure of wind will be perpendicular to this surface. Like this. Can you tell me how much this value? I can tell you 21.5, which is the pressure on this part, which is called P. So 21.5 times A prime times S. If you multiply these values at this location, 21.5 times A prime, which is this distance, times S, the spacing between each truss and the next truss, I can give you this value, this value, this value, and keep in your mind, the first value and the last value is half. If you are looking to determine what is the value here? This value or this value or this value or this value, I can tell you your pressure on this side of the building, 12.1. 12.1 multiplied by A prime by S. I can convert this pressure from uniform distributed load to concentrated load at each joint perpendicular to the surface of the truss. And keep in your mind, the first value is half, the last value is half of this. Since we don't have truss here and we don't have truss here, so this pressure will be converted as it is uniform distributed load, but your value must be multiplied by S only. So 21.1 times S. The second one, 22.3 times S. The third value, 23 times S. Hey guys, this or these values represent the wind pressure for the whole surface, this side of the building. I need to convert this pressure on the side of the building to pressure on one truss. This is the reason why I multiplied it by S, because each truss is supporting from center line to center line. Also on the other side, I will have uniform distributed load suction. How much this value equal this pressure, 16.7 times S. This is the truss that will be solved by RISA for wind. It's a long calculation, but it deserves. It's very important. If you can calculate your wind load on a building, you are professional. So I will go through them one more time. Guys, to solve example or problem or to calculate how much load do you have, we need first to calculate how much wind pressure on the building, each surface of the building. This side, this side, this side, and the other side as a surface. So first of all, what is the fluctuating pressure using this expression? I calculated the value of QZ. Since we have different value for KZ, I have QZ from 0 to 15, from 15 to 20, from 20 to 25, from 25 to 30. We have 30 to 40, but I stopped here because the total height or the H I'm gonna use around 31.6, which is very close to this level. And keep in your mind, the last value for QZ at your level H is called also QH. Then I will divide this structure to 4 parts. Windward wall, leeward wall, windward roof, leeward roof. Then I will calculate the wind pressure for each part. For windward wall, we have this expression. I will use QZ. Since we have different value for QZ, so we will have different value for pressure. Pressure from 0 to 15, from 15 to 20, from 20 to 25, to 20 to 30. And this pressure at these elevations from 0 to 15 to 20, 25 to 30 feet are pressure, pound per square feet, pressure on this whole surface. Then I will calculate the pressure on leeward wall. Looks like the equation is different a little bit. We are no longer have QZ. We have only QH, this side and this side. That means we have constant value. We don't have variables. So your value, pressure looks like this, and this pressure for the whole surface in the back. The whole surface in the back, but it's a suction. Then we have windward roof, which is this part of the building, this surface. Looks like we have this equation and the QH instead of QZ. So we have constant value, suction. And for Leeward roof, we have also this equation, QH constant value. So at the end, this is the pressure on the surface. I need to convert this pressure on the whole surface to only one truss, because we have many trusses here. We have one truss, and this truss is repeated, and this truss is repeated at spacing S. So I need to convert what is the load or what is the pressure assigned to one truss. So I need to convert this one pressure on the whole building to one truss. For the roof, I will multiply these values by A prime and S. And keep in your mind, the first point and the last point will be have these values. The same here. For your side, this side or this side, I will multiply these values only by S, because they still uniform distributed load. This is the final shape of your wind to be ready to be solved by RISA analysis. Do you have any question?